So by putting these dash lines, whatever you want to call them, I just like to call them barrier lines, and I want to see what's going on at those particular lines. So it split my graph up into three sections, right? This section, this is section number 2, this is that section, and section number 3 here. Okay. So it follows that just so happens that I have 3 different functions. Okay. Even that 2 is a function, it's called a constant function. So I'm going to need 3 flow charts, or t-charts, not charts. Okay, so t-chart number 1 is for the function negative x plus 4. I need an x and a y. I have to use the x value 0 for the first function, for the first point. But then the second one I get to choose because there's only one there. But it's got to be a number less than 0. So I'm going to choose negative 1. All right, so I'm going to actually put my actual value for x into the function. So 0, I'm going to substitute in 0 for x, add 4, and then 0 plus 4 is 4. So when my x is 0, my y is 4. Okay, then I got to plug in negative 1, so I have negative, my x is negative 1 plus 4. Double negative makes it a positive, so 1 plus 4 is 5. So when my x is negative 1, my y is 5. Then I'm going to look to see if my line here at x equals 0, so I'm looking at this point here where x equals 0, does it have an open or closed circle? Well, I look at to see if the inequality has an equal sign. This one does, so this point is a closed circle. So let's graph that. 0, 4, 0, 1, 2, 3, 4. It's a closed circle because of the equal sign with the inequality. Closed circle. And I need to graph this other point. Negative 1, 5. 1, 2, 3, 4, 5. And here's my line for section number 1. Okay. So for section number 1, first function, figured out what points to use. Okay, second section. We're using the function 2/3 x minus 1. 2/3 x minus 1. We need our t-chart, x, y. This time they're choosing x values for us for both points. I have to use 0 and I have to use 5. So those are those critical points that make these dashed lines here and these equations. Okay, so I plug in 0 for my x. So I have 2/3 times 0 minus 1. That's pretty easy. 2/3 times 0 is 0 minus 1. So my y value is minus 1. Now the 5, unless you're really good at fractions, when I plug in 5 for x, I'm going to use my calculator because I'm a little rusty with fractions. So I'm going to take 2/3, fractions you should be putting in as parentheses, times 5 minus 1. hit enter. And then I'm going to keep it as fractions because that's what we like to do in algebra 2. So math, enter, enter, and I get 7/3. So when x is 5, my y is 7/3. Okay, these critical points here, 0, -1, 5, both of these are critical points because I have 0 and 5. So let's see what's happening with each one of these. At my 0, there is no equal sign. This is going to be an open circle. At 5, I do have an equal sign. So this one's going to be a closed circle. Okay. So 0, -1, open circle. 5, and up 7/3, which is about 2 1/3, a closed circle. Now be careful when you're drawing this line. You want to stay within that section 2. Don't go past that vertical line x equals 5. Because that is for section 3. Okay, need a t-chart. By the way, it's for the function 2. It happens to be a constant function, so we really don't have to do any computation. I have an xy t-chart. I have to use the x value 5. And I need to choose one bigger because x is greater than 5, so I'm going to choose 6. This one's kind of easy because I don't have anything to figure out. There's no x to plug in. It's just the value 2. Let's look at the critical point. 5, 5, 2. No equal sign. So it's an open circle. Let's go to our graph. 5, 2, which is just underneath 2 1/3. It's an open circle. Then I have the point 6, 2. By the way, since I have same y values, this is going to be a vertical line at y equals. There's my piecewise function graph for this piecewise function. Any questions? I know it's a lot of work, it's a lot of detailed work, but if you're careful, it's not, and follow what you're doing here, the steps, it's not that hard. Now, function. Is it a function or not? Now, since we have a graph, we could do this pretty easily by using what? Right? Vertical line test. Remember, if it crosses my graph at more than one point, it is not a function. So I'm going to go along here. Let's see, 1 point, 1 point, 1 point. Let's look at this critical line here, x equals 0. Is this touching more than 1 point? It is not. It's going through this point, the 0,5 point, or 0,4. But since this is an open circle, it does not include the point -1. So we're okay. It's only going through that 1 point. Keep going. And we got the same situation here. One's closed, one's open, so it's only intersecting at 1 point. So this is, in fact, a function. Now, if any of these open circles were filled in, were a closed circle, this would not be a function because it would be going through 2 points. That makes sense? Got it, Matthew? All right. So let's do some evaluations, and then the rest of the class is yours. Let's look at f, the f of -2. Remember, we're looking at it when -2 equals x. So we're going to look at our domain restrictions here. Is -2 less than or equal to 0? Well, yes, it is. So we have to use that function, -x plus 4. So we're going to substitute in -2 for our x. -2 is a +2, plus 4 is +6. So the f of -2, +6. How about the f of 0? The f of 0, well, let's see. Is 0 less than or equal to 0? Yes, it is. So we have to use that top function. -x, I'm going to put parentheses around the x, plus 4. My x is 0. 0 plus 4? 4. We actually did that somewhere down here. And then we have the f of 5. Okay, 5 is it between 0 and 5 or equal to 5? Yes, it is. So we have to use function number 2, 2/3 x minus 1, substitute in 5 for x, and I believe we did this down here, right? And we got 7/3. Any questions on that? Got almost a half, 25 minutes today and 45 minutes tomorrow. Get these problems done. Think you can do it?